Okay, so for this video, we will be discussing the application of the derivative in determining whether a function is increasing or decreasing over a given interval. Okay, so this is practically very useful if we don't have the idea of how the graph looks. This can also be your guide when you are graphing curves. You will know how the graph looks. Okay, so based on knowing if the function is increasing or decreasing, okay, over a given interval. Okay, so but before we determine if the function is increasing or decreasing over a given interval, so first we must determine its critical points. Okay, so the critical points, so as I've discussed in the previous video, it is the point where generally it's the point where the trend of the graph changes, okay, from increasing to decreasing or decreasing to increasing. Okay, and using the second derivative test, so you will determine if it's your relative maxima or relative minima. Okay, so but those 2 points are where there is a change from increasing to decreasing, okay, trend. So in these types of problems, so what we are going to determine are the intervals, okay, or the value of x. Okay, so the values of x for which the function is increasing or decreasing. So it's important to find first the critical points, because those are the points where there is a change, okay, so in the trend. So obviously it will be the end limits of your intervals. Okay, so in determining whether it is increasing or decreasing, so we will simply use the first derivative test. Okay, so the first derivative, as we have discussed on the previous videos, so uh, the first derivative is indicative, okay, of the slope of the tangent line to the curve. Okay, so say for example, so in this part of the graph, so if we draw a tangent line here, so as we can see, the tangent line will have a positive slope. Okay, so because it's inclined to the right, okay, from left to right, so it is increasing. So similarly, the graph is also increasing. So take note, by describing if it's increasing or decreasing, so we are reading it from left to right. Okay, so on increasing trend, so from left to right, so this part is increasing, right? So from left to right. Okay, so it is described by a positive slope of the tangent. Okay, so since the slope of the tangent is also synonymous with the first derivative, then uh, then the first derivative test works. Sorry, the first derivative. So how the first derivative works is that if the so let me write it first. So first. Okay, so first, for the first derivative test, so if the first derivative is positive, so is greater than 0, okay, so therefore the graph is, or the function is increasing. Okay, so as you can also see, similarly, if we have here, so from here, from left to right, okay, so as you can see, it is decreasing. Okay, so any tangent line on that part of your curve, so the slope of its tangent is negative. Okay, so as you can see, it decreases from the slope of the tangent line decreases from left to right. Okay, so therefore, for the first derivative test, if the derivative is, is less than 0, so the graph is decreasing. Okay, so it's that simple. So the principle is very simple. So all we need to do is determine the intervals. Okay, so again, our first uh, goal is to determine the critical points. Okay, so because the critical points will divide the intervals. So it will divide the intervals from it will divide the interval, so in terms of decreasing, increasing, decreasing, and then increasing. So we must first identify those critical points. So say for example, so determine the intervals in which the function is decreasing or increasing. So we have here a very simple function, f of x is equal to x squared plus 2x. So our first, sorry, so our first step is to determine the critical points. So again, review to determine the critical points. At the critical points, the slopes of the tangent lines are 0. Okay, so therefore, we will set the first derivative to 0. So first, determine critical points. Okay, so to determine the critical points, we must first find the first derivative. So f prime of x is, we will derive this, so this will become derivative of x squared with respect to x, that is 2x, and then plus 2. Okay, so at the critical points, the first derivative is equal to 0. So therefore, 0 is equal to 2x plus 2. Solving for x, transposing, so we will have negative 2 is equal to 2x, divide both sides by 2. So x is equal to negative 2 divided by 2. X is equal to negative 1. So therefore, our critical point is negative 1. Okay, so when we find the critical point, then we will create a number line. Okay, so which will act as our interval. Okay, so this is x. Okay, so first we will find x is equal to negative 1. So say for example, this is our 0, and then this is our negative 1, negative 2, and so on. On the other side, so positive 1, positive 2, 3, and so on. Okay, so we will mark this critical point. Okay, because this will divide the interval. Okay, so therefore we only have two intervals. So one is from negative 1 to negative infinity. Okay, so until negative infinity on the left side. On the other side, from negative 1 until positive infinity on the other side. Okay, so we have two intervals. So this going there, and then from negative 1 going on the other side. Okay, so we will now determine if our function, okay, increases on this interval or decreases uh, increases or decreases between along the two intervals. Okay, so to do the first derivative test, sorry, so to do the first derivative test, so all we need to do is substitute any value, okay, on the left side of negative 1, okay, and on the right side of negative 1. Okay, so say we use negative 2. Okay, so to say to test whether the interval of negative 8 is less than x is less than negative 1. Okay, so this is how you write it. So meaning that is from negative infinity to negative 1. So to test whether the interval, this interval is increasing or decreasing, okay, so we will substitute any value between negative infinity to negative 1. Okay, so it doesn't matter what value you choose. Okay, so as long as you can determine if the derivative is greater than 0 or less than 0, positive or negative. Okay, so say we will choose x is equal to negative 2. So so our first derivative, f prime of x, is 2x plus 2. Okay, so if x is equal to negative 2, therefore this is negative, 2 times negative 2, okay, plus 2. So that will be equal to negative 2, right? So since it's negative 2, okay, so meaning this interval is decreasing. Okay, so that interval is decreasing. On the other side, so to test whether, so what's the other interval? From negative 1 to positive infinity. So for the interval negative 1 is less than x is less than positive infinity, then say x is equal to, so say for example you choose 2. Okay, so you choose x is equal to 2. So say x is equal to 2. Then the f prime of x is equal to 2 times 2 plus 2. So that is positive 6. Okay, so it's positive, it's greater than 0, so therefore the graph is increasing. Okay, so that's it. So that's the answer, okay, or the interval. So if we rewrite it, so it is answer here. So if it's increasing, so it's increasing from negative 1 to infinity. So it's increasing from negative 1 is less than x is less than infinity, and then this is decreasing from negative infinity to 1. So always remember that we look at the intervals from left to right. Okay, so from negative infinity is less than x is less than negative 1. Okay, so that is your answer. So there are many other ways to represent intervals, but I personally like this because it's clearer. Okay, so unlike the one that uses something that looks like a coordinate. So say for example, for this interval, so this one, they write it as negative 1 comma infinity, something like that. Okay, and then also this negative infinity comma negative 1. Okay, so because it confuses I don't like it personally because it's somewhat confusing because this looks like a coordinate. Okay, and also we have the use of the parentheses and the brackets. Okay, so when we say, so when it's a parenthesis, it's a parenthesis, then it doesn't include the end interval. Okay, so something like that. So say for example, we have an interval of 3 is less than or equal to x is less than infinity. Okay, so in this form, so since this is uh, less than or equal, so therefore the interval 3 is also included. So therefore we will write we will use bracket, so bracket 3 comma infinity, so something like that. So but personally I don't like it because it's not clear. So I personally prefer um, expressing the intervals this way. Okay, so let's have another problem. So okay, so another example. So determine the intervals in which the function is increasing or decreasing. So you have this function f of x is equal to 1 half x to the fourth plus 8x cubed plus 35x squared. So again, our first step is to determine the critical points. So get the derivative. So f prime of x is equal to, so how do we derive this? So we'll have 1 half derivative of x to the fourth with respect to x, that is 4x cubed, plus 8 derivative of x cubed with respect to x, that is 3x squared, plus 35 derivative of x squared with respect to x, that is 2x. So therefore our first derivative is, we have 2x cubed plus 8 times 3, that is 24x squared, plus 35 times 2, 70x. Okay, so the next is locate critical points. Again, the critical points will divide the intervals. So that's why we need to locate them. So the critical points will be obtained by equating the first derivative to 0. So we will have 2x cubed plus 24x squared plus 70x is equal to 0. Greatest common factor is 2 and x. So we'll have 2x times, this will become x squared plus 12x, and then this will become plus 35. 70x divided by 2x, so that is 35. Okay, is equal to 0. So next, factor this. So factor 35 such that the sum of the factors is 12. We'll have 7 and 5. So 2x times x plus 5 and x plus 7. Okay, is equal to 0. So now, equate the factors to 0. So we have 2x is equal to 0. Another one, x plus 5 is equal to 0. And then another one, x plus 7 is equal to 0. So here, dividing both sides by 2, so we will have x is equal to 0. Here, x is equal to negative 5. Here, x is equal to negative 7. Okay, so therefore, our interval will be divided into 4. We'll have 4 intervals because we have 3 critical points. Okay. Okay, so say this is our 0, this is our negative 5, and then this is our negative 7. Okay, so there will be 4 intervals. Okay, so the first one from left to right is from negative infinity to negative 7. So negative infinity is less than x is less than negative 7. So that is our first one. The second one from negative 7 to negative 5. So that is negative 7 is less than x is less than negative 5. The third interval is from negative 5 to 0. So from negative 5 is less than x is less than 0. And then the last one is from 0 to positive infinity. 0 is less than x is less than negative, is less than positive infinity. Okay. So actually, if we have open end, so you can also say its x is less than negative 7. So that's also okay. Oh, sorry. Yes, x is less than negative 7. Or here, for this one, so on the right side, you can also say that its x is greater than 0. Okay. So next is we test if it's increasing or decreasing. Okay. So we test if it's increasing or decreasing. So for our first interval from negative infinity to negative 7, okay, so all we need to do is select a number between negative infinity and negative 7. So say for example, x is equal to negative 8. Okay, so say x is equal to negative 8, so substitute it in the first derivative. F prime of x is equal to 2 times negative 8 cubed plus 24 times 8 squared, sorry, negative 8 squared plus 70 times negative 8. So using your calculators, where's my calculator? There. So we have 2 times negative 8 cubed plus 24 times negative 8 squared plus 70 times negative. So it's negative. So it's less than 0, meaning this interval is, our first interval is decreasing. Okay. And then we select another interval. So from negative 7 to negative 5. So for negative 7 is less than x is less than negative 5. So say x is equal to negative 6. Okay. So f prime of x is equal to 2 times negative 6 cubed plus 24 times negative 6 squared plus 70 times negative 6. So all we need to do is replace 8, negative 8 with negative 6, negative 6, negative 6. It's positive 12. So therefore, this is, the second interval is increasing. Okay. And similarly, so you can follow, so with this and with this interval. So I think maybe this is still decreasing. And then this is also increasing. It's just my guess. So just try it using the first derivative test. Okay. So how does this help with graphing? Okay. So you already know the trend if it's increasing or decreasing. Sorry. So therefore, it will be relatively easy for you to graph or sketch the curve. Okay. So, but before we do that, so you must locate the y-coordinate of the what you call this, the critical points. So again, our function, given function f of x is equal to, we have 1/2 x to the 4th plus 8x cubed plus 35 x squared. So we locate those 3 points. So at x is equal to 0, so critical points. So at x is equal to 0, so we will, sorry, x, y. So at x is equal to 0, y is equal to, what do you think? So substituting 0 here, so it will be 0. Okay, and then the second point was negative 5, and then we have negative 7. So if it's negative 5, then substitute there. So using the calculator, so we have x, sorry, we have yeah, alpha x raised to power of 4 over 2 plus 8x cubed plus 35x squared. So calculate if x is equal to negative 5. Oops. So this is 187.5. How about at negative 7? So it's, sorry, .5. Okay, so graphing it, then just estimating. This is our origin, this is f of x, and then this is x. We have the 3 points, the origin as our critical points, and then at negative 5, 187.5. So negative 5, have here negative 5, and let's say here is our negative 7. And then say this is our 187.5, and then this is 171.5. So the partner of negative 5 is 187.5. So here, and then there. So we have these 3 points. Okay, so for the first interval, we can see that it is decreasing. Okay, and then from negative 7 to negative 5 it's increasing, and then from negative 5 to 0 it's again decreasing, and then from 0 to positive infinity it's increasing. So therefore our graph will look like this. So from negative infinity to negative 7 it is decreasing, so therefore the graph is downwards, okay, from left to right. And then it's increasing from negative 7 to negative 5, and then it will again decrease, okay, and then from 0 to positive infinity it increases. Okay, so this is generally how the graph will look like. Okay, so this function. Okay, so without the traditional plotting of points, okay, so in traditional curve sketching, we determine all the values of y for all the values of x, and then we plot. Okay, so but for with the use of our idea of increasing and decreasing function, so then it will help us visualize our curve. Okay, so sometimes it is not necessary to have the exact curve, but it's necessary for us to visualize, okay, what the curve looks like. Okay, so that's all for this lesson. So it's very simple. Okay, so it's not a big deal actually, but the I think the difficult part will be in here. Okay, so in representing the intervals, so you need to review your algebra, okay, so on how to represent the intervals. So that's it, and thank you for watching, and good luck.